When you think of the word fishing, I imagine you see something including an ocean or a sea, a boat, a net, and a man with a pipe. Okay, maybe not the man with a pipe. And all of this is how the majority of the fishing takes place. There is also another technique that is used for 47% of the fish we consume, and it does not include an ocean or a sea. It looks like this, and it's called aquaculture. With the increasing effects overfishing has on the underwater system, you'd think, wow, this is great. However, this solution does come with its own problems. When feed is eaten by fish, it is metabolized into energy, nutrients, and proteins used for survival and growth. As with all animals, there are wastes produced by this metabolic process. Ammonia is the principal waste product excreted by fish. For many people who have heard the word ammonia in a context, it would most likely be heard as a disease. But before you go crazy thinking that any water inhabited by fish will give you diseases due to ammonia, listen closely. It definitely isn't all bad. In fact, of all water quality parameters which affect fish, ammonia is the most important after oxygen. Low levels of ammonia can make fish susceptible to bacteria infections, poor growth, and will not tolerate routine handling as well as they should. However, high concentrations of ammonia can also be toxic to the fish, as it increases the chances of them getting diseases. This would normally not be a problem in the open ocean or sea, as the ammonia concentration is usually outweighed by the large quantities of water in the sea. However, where can this become a problem? You guessed it, in aquaculture. Here, there's a lower ratio of water to fish, and if the fish we eat gets diseases due to ammonia, then there's a chance of human meeting this fate too. But like any problem, there is a solution. And it involves a system called aquaponics. Aquaponics is the combination of aquaculture, which is fish farming, and hydroponic, which is the soilless growing of plants. This grows fish and plants together in one integrated system. Aquaponics uses these two in a symbiotic combination to which both the plants and the fish meet their nutritional requirements to thrive and grow. To understand aquaponics, let's break down the sections of the system. Step 1, nitrification. Let me break down how nitrogen is broken down. It all starts with nitrogen, which goes into the system in the form of protein, which is given to fish in their feed. The microbes in the fish's gut break down these proteins into amino acids and then into ammonia. The so-called nitrifying bacteria can then oxidize the ammonia and break it down into nitrite and then nitrate. This then leaves the fish's body in the form of organic waste. This is now accessible for the plants. Which brings us to step 2, plants intake. Too much of these nitrogen compounds created is toxic to fish, but to plants, this is a nutrient-rich fertilizer. They take in these nitrogen compounds through their roots and use it for all functions in their body that require nitrogen to thrive. For example, nitrogen is a major component of chlorophyll, the compound by which plants use sunlight energy to produce sugars from water and carbon dioxide. Nitrogen is also a major component of amino acids, which is the building blocks of protein. As they take in these nutrients, they are also cleaning out the water, in which plants swim in, which virtually eliminates the risk of fish getting diseases due to ammonia. Okay, so let's discuss the social values and circumstances with aquaponic systems. Starting with advantages, aquaponic systems can be grown virtually anywhere, as the water is recycled and the plants can be grown indoors. The nutrients produced by the fish requires minimal add-ins. As this can be grown in a variety of different places, we can implement this into communities where food can be hard to grow in other ways. For example, in a hot climate such as the desert, food can be hard to be provided to communities living in such areas, and an aquaponic system sources protein from the fish as well as an abundance of different varieties of nutrient-rich plants. With this system spreading to developing countries, the lives of these citizens improve by increasing food security, employment opportunities, and economic growth. However, disadvantages can also be found in the solution. Rural communities must be supported in training in aquaponics, as well as knowing how to look after the fish, plants, and system. There needs to be an ongoing support as long as the project exists. To many people, the idea of fish having to live their whole lives in small tanks such as these can be seen as a form of animal abuse. especially at a newly built aquaponic systems where the pH levels are still not in balance and there is a higher risk of some fish being sacrificed before the system has controlled these variables that may threaten the fish. As of now, majority of aquaponic systems can only harvest low-protein crops such as leafy greens such like lettuce, basil, and in some cases tomatoes. If you want to grow fruits and other higher protein vegetables, you need a more concentrated system with more fish producing more waste. In order for this to happen, aquaponic farmers must be supported by the government. Aquaponics must be more known to society in order for them to further develop and replace some of the other forms of growing plants and fish. Only then can we take advantage of this phenomenal symbiotic cooperation between these two different species and feed humanity with these remarkable capabilities nature has.